Hi there, welcome back. Well, we've finally arrived at the part that I've been most anxious to start, and that is the RF alignment of the shortwave 3 to shortwave 10 bands. And as I said in the end of my last video, when I RF aligned the others, this part I hadn't actually looked at, but the first challenge was removing this plate. And as it turns out, it's no big mystery. It's got two clips. It's got a clip there and another clip over there. Okay, and this thing just fits in there. These two ends, these two little wings get clipped in there, and this one serves as a guide to go in there. You see there's a vertical division on there. So it just literally goes like that. You've got to be careful. Don't force it. But there we go. So to take it out, I just put my fingers in there and it comes out. Now, obviously what you're seeing here is it's got nothing to do with this particular band. What you're seeing here are the settings for whatever's showing on the front. And in this case, it is shortwave 3. So we're going to be aligning this one. And this one starts at 5 megahertz and goes to about 6.6. That's what we are going to focus on now. And it's actually a lot easier than I expected. Let me show you. Effectively, they give us for each of these bands, there's the range of frequencies, but they give us two alignment points. And again, they're giving us a lower end and a higher end. In this case, the low end is 5.2 megahertz and the high end is 6.5 megahertz. And then, of course, we've got the usual signal levels and image rejection ratios and everything else, which, as I said, I'm not going to bother with these because my equipment is not calibrated to the extent that I can actually measure these. So I'm just going to do exactly the same as I've done with the others, with the other bands, and that is I'm going to send a signal of 5.2 megahertz with an audio tone modulated on there, 30% modulation. And I will first set it to 5.2, make the necessary adjustments, and then set it to 6.5 and make the necessary adjustments. Now that is for the broadband, the normal band, as they tell us to set to the normal band. In other words, we are aligning the bottom end. And what they do then is they give you one adjustment for the top. In other words, the commercial band within this shortwave band. And the only description I have there is on this particular drawing, where they tell us that for the 49 meter band, you have to align it at 6.1 megahertz. And it doesn't tell us much else. So I sort of had to figure it out, and it's not difficult. Let's have a look at the schematic, and that'll explain everything. Here we are again. This is the part of the circuit we saw yesterday, and before I carry on, I just want to correct something here, and I want to thank Stefan for the clarification. I said this is the antenna tuning front end, and it is. I said this is the oscillator, and it is. I said that this was the mixer, and that is incorrect. This thing actually has better pre-selection than I expected. And the way this works is you've got some pre-selection here. You tune the front end. Then there's this amplifier, which amplifies the tuned part of the band. That goes onto here. And this is a second tuned circuit for each of the bands, which then takes your RF signal, your input antenna signal, properly selected twice. In other words, here and here, and sends it to this transistor, which is the mixer. This is the oscillator. That is the oscillating transistor. And if you look at this transistor here, which we know now is the mixer, the way this works is Your RF front end comes through here, and that is mixed with a signal which is fed through this capacitor here that comes down here, down here, down here. So this is your oscillator signal that goes up and gets fed to the emitter of this mixing transistor. Your intermediate signal then comes out here. In fact, various signals come out here. The one you want is the one you're going to select as your intermediate, and that is the first IF filter, as it were. So that then goes off to your IF block further ahead. But anyway, that's just to clarify a little mistake that I made here. Quite a big mistake, actually. But we're interested in this section here. And the way this section works is this circuit does the job for all the bands from shortwave 3 to shortwave 10. And of course, because you're dealing with different frequencies, you need different tank circuits, different filter elements. And the way they've done it is basically they've got 1, 2, 3 blocks of circuitry that get rotated in as you tune, and it makes perfect sense. You've actually got your oscillator down here. Depending on which band you're on, the different components here will bring that oscillation to that band. You've got an intermediate stage here, similar to the previous one that we saw down here, I believe. And you've got this sort of antenna front end. So these blocks here are the various blocks that you see on that drum. And we will see there are 3 groups of sections, 3 sections per drum. And we will be adjusting all these separately. Now, the one thing that I was a little bit baffled about was how do you adjust for that, for the spread, for the band spread? And it becomes pretty obvious when you look at, for example, this one over here. If we look at this section here, what we have is, we have a CZK, that's that capacitor, that trimmer cap. You've got an LZK, which is that inductor. And then there's something called the bund. Now, the way I understood it was this. If the bund is on, the circuitry that's operational is this side here. If you've got normal band, the circuit that's operational is this part here. And what is this part? Well, this is part of the tuning condenser. If you remember, there was that tuning condenser that was stuck. It has a lot of legs on there, a lot of sections on there. And what they do is this section comes in and does your tuning for your normal band. So if you've got a normal band, you can set the bottom end of the tuning, 5.2 I think it was, for example, in that band. Set that with this inductor. You tune to the top end, which is 6 point something megahertz, and you adjust. And in this particular case, you're adjusting for peak, but if you're adjusting the oscillator, you're adjusting for the oscillation point. And then when you select band, you have one point that you have to adjust. And that is a capacitor, this capacitor that comes in series with this trimmer. And what happens then is you're adding a capacitor to the band. You're basically making the capacitance level, the range of capacitance that you're using, different. And that makes sense because it just takes the whole tank circuit and it focuses in on a section that you want, depending on how you tune that one there. That still comes into play, but the one you're using is this one. And so theoretically, if these two are well adjusted, and if everything else is well adjusted, then simply by bringing that capacitor in and doing the normal tuning with this condenser now, the interaction of this capacitance in conjunction with that and that will give you the range within that band that you want to tune to. So it makes sense. So the thing to do is we leave it on normal band, and you see the same applies here. This is the antenna front end. You've got LVK, Vorkreis, that's the inductor for the front circuit, Vorkreis. The CVK, it's that trimmer. And then when you tune in, when you click in the band spread, then this condenser comes in, and this one is then set in in series with this one here. And you're tuning this one, and depending on how you've adjusted this, the span within that band should be correct. So that's what we need to do. We need to adjust. We leave it on normal band and we adjust. In fact, I'm going to do it in this order. I'm going to do the oscillator. So in the case of that shortwave 3, I'm going to send a signal at 5.2 megahertz as they tell me to, and I'm going to tune the dial to 5.2 megahertz, and I'm going to adjust this oscillator. This is LOK, Oscillatorkreis. Hey, I'm going to start speaking German one of these days with a bit of help from my friends. But so I'll adjust that guy till I get it spot on 5.2 megahertz. Then I'll tune or send a signal at 6.5 megahertz, also with a tone. I will tune on the dial. I'll set the dial to 6.5 and I will adjust that guy. Then I'll come back to this one, go back to that one, make sure those are fine. And then I will select the band, in other words, from normal band to band spread. And that one, they tell us, I need to peak at 6.1 megahertz. So I will then send a 6.1 megahertz signal. I will tune to 6.1 on that orange band, and I will peak it with this particular guy. And that's about all you can adjust there, unless you want to go into some of the other components that are floating around. So I'll do that for the oscillator. Then I'll do that for the front end circuit or the intermediate. I'm not even sure which order I'm going to do it in. So yeah, the intermediate's in the middle, so I'll probably work backwards. I'll probably do the intermediate. I will set it again at the bottom end. It's 5.2, and I will peak the tone with that one. I will then set it at 6.5 and peak the tone with this one. And I will set it on the band spread and send a 6.1 megahertz signal and peak the tone level with this band switch. And then of course I'll do the same with that one. And then of course I have to rinse and repeat for all the bands. So I'm going to show you one of them and then we will extrapolate from there, and then I can show you the result as I did with the previous video, the result on all the bands. I know that I can get the normal band pretty accurate. I know I can. I am not sure just how accurate that commercial band tuning will be, because this band tuner adjuster is only one adjustment. It's not the bottom end and top end. It's basically in the middle. You adjust it and you sort of rely on the components that are there to make sure that the spread is what it should be. But we'll check that as well. Okay, let me get on with it. Setting the first transmit point, 5.2 megahertz with a modulation. Clipped again just to the edge of that plastic so that it's coupled but not touching the antenna input. External antenna is selected. Shortwave 3 to 10 button is depressed. And just to see where it's coming through, it is just below 5.2. There's the 5.2 little nugget there. It's just to the right of that. So I'm going to set it to 5.2 exactly. And we'll tune the back. And I'm going to do this oscillator first. That's the coil on the oscillator. I've got the meter connected to the output. I'll just keep an eye on that. Okay, that was easy. Put the volume down a bit. That was the oscillator. This is the intermediate. I'll do that now. That went up quite a bit. And this is the front end. Yeah. That went up a heck of a lot. Okay, good. I'll set it now to 6.5. Tune to about 6.5. That's that guy over there. That's 6.5 exactly. And now I'm going to tune this one here, which is the condenser, the trimmer. That is pretty sensitive. Put the volume up. This is ceramic and it's still affecting it. I'm looking at the meter and I'm trying to trim it to the point where it goes to max when I pull it away. Okay, that's a max. I'll do the intermediate as well. What I'm going to do, because this is sort of stuck with probably varnish, I'm just going to break the seal on these trimmers with a metal screwdriver. Although it doesn't seem to make any difference because it seems these are grounds. But then I'll use the ceramic one. That's pretty much peaked. Let's do the front end one. Whoa, this one went up a lot. Okay, good. That's done. Let me try again. I'll do another repeat on those just to make sure that I've got them properly tuned. And then I'm going to do the band spread one. Now I'll set this one to 6.1 megahertz as they instruct. We'll set the band to the top one. And we'll go to 6.1, which is over here. It's a bit off. So I've got to try and get it just to there. And that is done with these three trimmers. That's the oscillator. I'm just going to break the seal on all of them. I think there might be a little bit of a lacquer seal or something. Okay, now I can use the ceramic one. Put a bit more volume. That seems to be a peak. It went down. That's a peak. That went up just a little bit. And that went up just a little bit. Let me just check the tuning in the front. It's just a little bit off still. That's peaked. And that is peaked. And it looks like we've done it. Let's check the results. Set it to 5.2. That is slap bang on there. Let's try 6. See how accurate the intermediate stages are. Slap on 6. That's great. 6.5. Yep. This is very difficult to see exactly down here because all you've got to do is look a little bit to the left or a little bit to the right and you've got parallax playing tricks on you, but it's slap on. Let's now go up to the upper band and let's try 6.1. It's actually just a wee hair to the right. I'm just going to adjust that for a sec. Okay, that's smack on 6.1. Now let's try 6 on that range. See, as far as I'm concerned, that is a little bit to the right. Let's try 6.25. That is smack on 6.25 if you look straight down it. So, okay, 5.91. Let's try that. That's on that end. Well, yeah, I guess it's just a little notch to the right there. Not exactly spot on, but as I said, with this top band, you're actually adjusting a span. And it depends on so many other factors that I'm not surprised it's not absolutely accurate. But yeah, I guess that's what it is. You could go and just tune the top one, but that would mess up the bottom one. So that one is done. That, my friends, is shortwave 3 aligned as well as I can align it. And I don't think I could do anything different. If you know of something different, let me know in the comments below. I'm always open to some learning. All right, now what I'm going to do is I'm going to go ahead with all the others, and at the end I'll just show you the results. By the way, the one thing you do when you've got this thing out is you clean it, so that when it comes around to its turn, in other words, what is that, shortwave 7, and this comes up at the front here, it'll be nice and clean. You can see it's got quite a bit of dirt on there. I'll probably just polish that plastic, and so we'll have something good as new. All right, let me carry on. All right, we've come to the interesting part. All the bands have been done up to shortwave 9. Now on shortwave 9, they tell us to set the lower end to 18.7 megahertz, and that's a little notch just there. Okay, 18.7 megahertz, and adjust the bottom end. Now remember, this is still on the lower end and it's still on narrowband. So 18.7 with the modulation. Let's see where it is that I'm actually getting it. Oh, it's quite a bit off. So set it to 18.7 exactly, and I'm going to adjust that one while you keep an eye on the meter. Try one way first. Nope. Oh, there it is. Whoa, this is really sensitive. Put the volume down a bit. About there. This is really touchy, this one. Just a little hair and it bounces right off. Okay, that's it. Now I'll do the intermediate, which is also the inductor. Oh, that's nice. That's a peak there. Okay, now the antenna, also the inductor. That's moving quite a bit. I'll have to put the volume down again. Bloody hell. Bloody hell, what is this? Oh, there's a peak. Okay, now there's an explanation for that. I think it depends on the setup that you use, what kind of signal generator you use, its impedance, how close it approximates an actual antenna, and all that stuff, because this is the front end tuning, okay? But we'll leave it at that and look at the next step. Here's our little problem. The next one is 23 megahertz. And my signal generator goes up to 20 megahertz. So what are we going to do? I'm going to set this as per normal to 23 megahertz, which is over there. Okay. Now here is my problem. It won't go any further. So I've tried something and it works. I did some experimentation. I can use square wave, but it won't give me 20 megahertz. It'll give me 5 megahertz maximum. Now square wave has got all the harmonics, or as many harmonics as you probably want, as long as they're odd. Square waves will give you odd harmonics. In other words, besides the 5 megahertz, because of the characteristics of the square wave, it won't give me 10, it'll give me 15, it won't give me 20, it'll give me 25. So we're getting there. So fifth harmonic on there, if I divide that 23, what is that, 23? 23 divided by 5 is 4.6, is it? I think it's 4.6. So if I go to 4.6, that's 23. Now let's see if I'm receiving it. Now I'm sending a 4.6 megahertz square wave with modulation. I'm not quite sure how the modulation operates on a square wave, but let's see if I can find it anywhere near 23 megahertz. I can hear something. Let me turn off the signal generator, see if it disappears. And it does. So I'm getting something. So what I'm going to do is I'm going to increase the signal strength, see what happens. Ha! Beauty. We've got it. We are listening to the fifth harmonic of 4.6 megahertz modulated. And it's just out. It should be there. So let's go back to the back of this thing. And now I'm going to adjust, I'm at the top end, I'm going to adjust that one, and that one, while you keep an eye on the meter. I'm going to give it a bit more signal strength. See what happens. See, when I bring my, I'm just bringing the ceramic screwdriver close and it's affecting it. So I need to adjust it and move away. If I move away, let me see whether it stops at a peak. Let's basically go in, just slightly move away. It's actually got bigger. I'm actually reducing the signal strength again. All right, let's try that. We're on, what is it, 8 on the top. We've got a little bit more. I'm happy with that one. Now I'm going to do the intermediate. Better bring the volume down to a level where we can actually see changes. There's my peak, and now the antenna circuit. If I could fit it in. Okay, here goes. Same story. We're making major adjustments on the antenna circuit, and I'm not sure that's a good thing. We'll discuss it in a bit. Bloody hell. I've got to bring the signal down again, and the volume. That seems to be a peak, and I've done it. It's peaked on 23. Now we'll do that commercial band one. The commercial band adjustment here is on 21.6. You can see the little notch there. So again, I'm going to use a fifth harmonic. So 21.6, set it exactly. Put this to the upper band. And now I'm going to adjust that one, and that one. And to get to that frequency, I've worked out that the fifth harmonic, it's the fifth harmonic of 4.32 megahertz. So that's what that is set at. Whoa, it's quite far off. So let me put it back on there. And start with the adjustments. Whoa. Lower the volume there. This is the same problem. It's very sensitive. That seems to be about as high as we're going to get it. Okay. Now the intermediate. That's quite a nice change. And now the aerial, or the antenna. Ooh, drop the volume. There's our peak, and we're done. That one's done. Now this thing has been cleaned. And I can fit it back very gently. Boom, it's there. Next one. We're looking at shortwave 10, the last one. All right. It's basically a rinse and repeat. Now what we've got here is 24 megahertz as the bottom end. And again, we have to play silly buggers with the fifth harmonic. And that is the fifth harmonic of 4.8 megahertz. So let's flip around. So I'll set the signal generator to 4.8 megahertz. And I need to adjust that one, and that one. The three inductors. That's our peak. Okay, that's peaked. All right. Now, what's next? The next one over here is at 29.5. 29.5. Now, I can't get to 29.5 with my fifth harmonic because 5 times 5 megahertz, which is my limit, is 25 megahertz. So I have to use my seventh harmonic and hope it's still there. And seventh harmonic, so if I take 29.5 megahertz divided by 7, I get 4.214 megahertz. 4.214 megahertz. Hit it. See if I can hear it at all. Ha, it's there. It's weaker, so I'm going to give it a bit more amplitude. That's pretty good. Okay, so I'm going to set it to 29.5. Go to the back. And I've got to adjust that guy, and that guy. There's my peak over there. Okay, that one's done. Now I've got to do the upper one, which is at 25.8 megahertz. Let's see what that gives us. And 25.8 megahertz divided by 7, I still have to use the seventh harmonic, is 3.6857 megahertz. That's what that's set to. Let's hit it there. Let's see if we're getting anything. Upper. Oh yeah, we are. Drop the amplitude. It's pretty close. That's where it is there. So we'll set that at the back. And again, just for complete disclosure, I'm adjusting that guy for frequency, that guy for intermediate, that guy for antenna. Keep an eye on the meter. And antenna. Bloody hell, I don't understand this. How can some of them be so far off and others not? It's the same antenna. I wonder if it's got... yeah, it has to do with the antenna tuning. I put it in the middle, so this is the antenna tuning effect. Okay, makes sense. Antenna was set to the middle, which is a good thing, because I'd have to redo everything otherwise. Okay, we are done. We are done. So, shortwave 10 is done as well. And I realized one of the probabilities actually, is the actual antenna tuner. Let me show you what I mean. There's the antenna tuner. Now, I have adjusted this not for the rod antenna, because I really don't believe I'm going to get anything on the rod antenna, but rather for the external antenna. And I use a long wire or mini whip for that. So the fact that this thing is straight in line with the antenna signal that's coming in means it does affect the tune circuit at the front end, which is what it basically is. This is part of a tune circuit. There's a little capacitor in there, which you adjust from 0 to, I think, 100 picofarads. So that would make a difference, and that makes sense. Now I had set this, I believe this is about halfway where it is now. I had set this originally, so any discrepancies we should be able to tune anyway. Fair enough. Live and remember. Live and learn and remember. Okay, let's do some checking and see what we've got after all this. Just so you know, I was using this dummy antenna to do the alignment. And the reason I did that is because my signal generator has a 50 ohm output impedance, and that's not what this thing expects to see. And because I want to tune the antenna circuits, the front end, which is very sensitive to the whatever's connected to it, in this case a 50 ohm impedant load, which certainly is not what a real antenna would look like, I built this dummy antenna, and I've got a video on this particular little project. It's the attenuator, stepped attenuator, switchable attenuator and dummy antenna, coming up very, very soon, probably in a day or two. So the settings here were not done directly from the signal generator, or indeed simply by transmitting the signal over the air from closed coupling. I've actually used a dummy antenna. Anyway, let's carry on. Let's have a look at the result. Well, you've actually seen the last few that I did, so there's no point doing that. Let's go to our usual 7 megahertz. The signal's far too strong. There's 7 megahertz. Slap on 7 megahertz. Brilliant. Let's have a look at 7.1 on the top one. 7 point, well, I was doing 7 before, wasn't I? So let's just try 7. It's just off by very little, 5 kilohertz. That'll be 7 exactly. That'll be 7, that's where it is. So just off. Let's try another one. 9. On the bottom scale. Perfect. I don't know if you see straight in there, but that's 9. Let's try 10. There's 10. So let's try 12. There's 12. So folks, I'm very pleased with the result. And that is the RF alignment of the shortwave bands. Now, I get to this point and I think, what else? I know there are a couple of capacitors, still some electrolytics, one down there, 2 up here that I need to change. I think I'm going to leave FM well enough alone. I think I am. I don't think I want to mess with that. I don't want to try. I can't even think of 7th harmonic. I'd have to do 21st harmonic or something stupid to get up high to those points. And I'm sure I'm going to mess it up. If any of you have got a really high frequency RF signal generator you want to donate, go for it. I need it. It's just not something that I use often, but you would need it to align it accurately. I can see the 88 is one of the markers. 106 is the other marker. The little trick that I use with a little transmitter thing, I don't want to touch this. I don't want to risk this radio with that little transmitter thingy. It's just not accurate enough. It's just not secure enough. And so I'm going to leave well enough alone. So what have we done? We've done the RF alignment for all the bands on the AM section. So long wave, medium wave, short wave 1 all the way through 10. We've done the alignments, and I must admit I'm actually quite surprised at how accurate that top band is, because when you adjust the bottom band exactly, then you're just trimming a condenser on the oscillator and the middle and the intermediate and the antenna to peak it for that commercial band, stretch band, or whatever the band spread, that if you want to call it that. So the fact that it's actually quite accurate at the set point, like this one, it's supposed to be at 11.8. It's very accurate there. But then it's got to go from 11.6 to 12.1. It misses a little bit here and there, as you saw with the 7 megahertz one. but it's not bad at all. This thing is now, hey, it's optimized. And I'm really pleased because this one is a keeper. This is the one I've been wanting for a while. Probably going to set this in a competition against the BRAUN T1000 CD if my friend is watching. I think I might lose, but it would be fun. Same antenna and do some measurements. It would be fun. I probably would lose. Don't know. Maybe. This thing is double conversion, the other one isn't, but we'll see. So for now, that's going to be the end of this video, and I hope you have enjoyed it. I certainly have. I was sort of dreading that section, but once you get going, hey, it's actually quite easy. Oh, there's one more thing. I've got to change that bulb there. So I've got quite a few things to do, and you might have noticed I'm avoiding the obvious, which is the cleaning of the chassis, which I've actually done part of, but I'll keep you in suspense till the next video. I'm going to finish the cleaning of the chassis and then do the final touch-ups, put this in, and show you the final result, and we'll do some tests. So I want to thank you for watching. I hope you've enjoyed that. If you have, please click like, and if you really have, then you can share it on social media with all your buddies and members of groups and all that sort of thing. And if you want to support the channel directly, you can do so on Patreon. The links are at the end of the video and in the description below. So once again, thanks for watching. Bye for now and stay safe.